Welcome back to Applied Algebra. We are moving on to section 2 in chapter 7, and we're doing proportions today. So a proportion is simply when you take two ratios and compare them. So remember, a ratio is a comparison of two numbers. A proportion is a comparison of two ratios. So let's write our definition with my pen that's not working. And what we tend to do with this is we take two ratios and we set them equal. That's how we're going to compare them. So I have some examples down here. So I have a ratio of x over 5 and I have another ratio of 10 over 14 and I want to compare them. So what we want to do algebraically is we want to get rid of these denominators. So if you think back to chapter 6 when we got rid of the denominators, we would think about what do they have in common. And 5 and 14 do have a number in common, but it's a large number. So what we can do is multiply each one at a time. So let's just multiply by 5 to start with. So that's going to give me 5x over 5. I'm distributing. And 50 over 14. So the 5's cancel, so I'm left with x equals, so let's think about 50 over 14. If I reduce that, they're even, so it's 25 over 7, which you could leave as an improper fraction. You can make it a mixed number. 7 goes into 25 3 times with 4 left over. And I do want exact answers, so if you change that to a decimal, it doesn't, well, it does. It's kind of crazy looking. It looks like this. It's 3.57142.8 before it starts repeating. So that would be its exact form. So I would say it's easier to go 25 sevenths or 3 and 4 sevenths, but you can make your choice. Now that works out nicely when your variable's on the top. But now when your variable's on the bottom, then you'd have to multiply by the a to get it out of the bottom. So if I tried that, we would end up with 2a over a equals 5a over 14. These a's would disappear. So now I have 2 equals 5a over 14. So I still have this denominator, so I got to get rid of that one. So now I'm going to multiply by 14. Distribute. 14 times 2 is 28. 14 times 5 is 70. But I'm dividing by 14, so it's going to take me right back to 5. So I end up with 28 equals 5a. If I get the 5 by its, or the a by itself, I have to divide by 5. So I end up with a is equal to 5.6. So that one turns out nicely because it's 3/5. Now you might ask yourself, that was a little bit crazy trying to get all the way through there. And so what you may have experienced if you've had a previous math teacher, which I'm sure you all have, is when you have something that looks like this, they talk to you about what's called cross multiplying. And what that is it's a shortcut to go through this whole process. So I'm going to show you here what that means. So I'm going to get rid of this. So to cross multiply, you multiply diagonally. And we're allowed to do that because of all this math that I already showed you. So a times 5 is 5a. 2 times 14 is 28. Now if you have trouble remembering what to do, if you look at that where you go diagonally, it looks like a multiplication symbol, so that helps you remember to multiply. Now that you have it looking like a regular equation, now you can remember I just need to isolate the a. So I'm going to divide by 5. So again I end up with a equals 5.6. So you can go straight to this method. if you don't want to go through all this. So this is the algebra part that I showed in the first step here, and then this cross multiplication is the shortcut. So if we go ahead and practice the shortcut, we're going to multiply diagonally. So it's 11 times 4x equals 6 times 25. Now it doesn't matter who you put on which side. If you prefer to always start with the top, you could put 6 times 25 first. 11 times 4 gives me 44x. 6 times 25 is 150. I'm going to go ahead and divide by 44. Again, it's not a great number, so x is equal to 3, and that would be, well, that's 18 over 44, which can reduce 9/11. So that would be the exact mixed number. As a decimal, it's 3.409, and the 09 repeats. So again, you choose how you want to give me your answer, but I do want an exact answer. Okay, so D, it looks a little bit more scary because it's got bigger numbers and decimals, but the process does not change. So just keep the same practice, the same method. So I'm going to go 205 times 4320, 47.1 times x. So I get 885600 equals 47.1x. I'll just go ahead and divide by my 47.1. X equals 18802.547, the 7 repeats. Okay, let's look at a situation or two. We need 3.75 cubic feet of sand to make 9 cubic feet of concrete. How much, nice typo, sand would you need to make 239 cubic feet of concrete? So we can set this up in a proportion. These are what I know together right now. So it doesn't matter who you put on top, just be consistent. So I'm going to do sand over concrete. So 3.75 over 9, and I don't need the units because they're the same. Now how much sand would I need to make 239 concrete? The concrete is the C, so that's the bottom number. And I'm looking for the sand, which is the top number. So now that I have it set up, I'm going to cross multiply. 9x equals 3.75 times 239. I get 896.25. Go ahead and divide that by 9. So I need 99, let's get that into something besides a decimal. It's a little over a half, so it's 99 times 9, which is 891. Oh my goodness, it is a mess. So I'm going to go ahead and write 583. And that's how many cubic feet. So as the contractor, they're going to probably just do 99.5. And then they've done it enough to know if that's working or not. An orchard has 4 rows with 6 apple trees each. The apple trees yield 290 bushels of apples. What was the average yield per tree? 4 rows with 6 apple trees each. The apple trees are 299 bushels of apples. Average yield per tree. Okay. So we've got to figure out how many trees we have. So if we have 4 rows, and each row has 6 apple trees, we know we have 24 apple trees. All of the trees together gave us 290 bushels. So to find out per tree, we're going to take the total bushels and divide by the total trees. So 290 divided by 24 tells us that each tree gave us a little bit over 12 bushels. Now at $24 per half bushel, what is the income from the sales of the apples? So I get $24 for every half bushel. So this is money, and these are my bushels. What is the income? Now I know I sold 290 bushels, so that's going to go on the bottom. And then my top will tell me how much money I made. I'm going to cross multiply. 24 times 290 equals 0.5x. 24 times 290 is 6960. Since I need x by itself, I'm going to go ahead and divide by that 0.5. Should go up, and we end up finding out that we made $13,920 for those 290 bushels of apples. So a couple more examples here. When finding the percent, round to the nearest tenth of the percent. At the beginning of a trip, a tire on an automobile has a pressure of 43 psi's, which are pound per square inch. At the end of the trip, the pressure is 49 psi's. What is the percent increase in pressure? So we have to know that percentages are out of 100. So our percent will always be out of 100. So if you think about your grades, you always get told on your test and stuff, it's whatever your grade was, right? You got a 95%, you got 95 out of 100. And so at the beginning of the trip, it was 43. At the end of the trip, it was 49. Now it changed, right? It went from 43 to 49. It increased. So how much increase was that? 49 minus 43 is 6. So it increased 6%. What did it start with? Because these are always out of what they started with, which is out of 43. So now that I have it set up, we're going to do our cross multiplying. 43 times x equals 6 times 100. Go ahead and divide by our 43. So our pressure increased approximately 14%. I got 13.95, so I rounded to 14. On that one, just be careful. You always have to find the difference, whether it's an increase or decrease, and make sure that that difference goes on top and the beginning amount goes on the bottom. Find the number of milliliters of pure ingredient needed to prepare 260 milliliters of 4% alcohol solution from pure solution. So I need 260 milliliters of 4% alcohol solution. So I actually find this easier for me to think about if I was actually standing and doing it. So here's my container, and I need 260 milliliters at 4%. So this is my final result. I've actually changed my mind. I'm going to switch this. We're going to go ahead and stick with this idea of percentages and proportions. So it's out of 100, and so they want us to have 4%. So that's our 4 out of 100. Now the 100 is the entire amount, and the 4 is just the alcohol. So this is the percent of alcohol, and this just means it's the entire container. The entire container contains 260 milliliters, and they want to know how much of this pure alcohol do I have to put into it. So now that I have my proportion, I'm going to cross multiply. So 4 times 260 is 100 times x. 4 times 260 is 1,040. I'll go ahead and divide by my 100. So in order to end up with 260 milliliters of 4% alcohol solution from a pure alcohol solution, I only need 10.4 milliliters of pure alcohol. The rest would be water. So I have a similar situation with powdered sodium bicarbonate. Find the number of grams of pure ingredient needed to prepare 600 milliliters of a 2% sodium bicarbonate from a pure powder. So we're going to go ahead and do the same thing. We're going to keep it with a percentage problem. This is our entire amount. This is what we're looking for, which is our sodium bicarbonate. We need 2% sodium bicarbonate, and we have 600 milliliters total. And we're going to find out the amount of the pure sodium bicarbonate. So I'm going to cross multiply. 2 times 600 is 100 times x. 1200 equals 100x. Divide by 100. And so we will need 12 milliliters of the pure sodium bicarbonate in order to end up with a 2% solution. Okay, go ahead and work through your proportion assignment. Let me know if you have any questions, and I'll see you back for 7-3.